Okay, so this will either be an introduction or a review, depending on who you are, of one of the concepts that can sometimes be a little bit tricky in chemistry. It is something called dimensional analysis, which sounds way harder than it really is. The real big issue with dimensional analysis is lots of times people really don't understand what in the world it's for. So you got to understand the purpose first, and then you got to understand the pattern. If you can do the purpose and the pattern, you can do this, and you will need this for the rest of the year. So let's start with the purpose. Okay, we learned in class about the metric system. So the way that lots of us teach the metric system is with a staircase. Okay, everything with the metric system is just about moving a decimal. So if we put our base unit here, okay, let's say that is a meter, okay, so that's a meter, which is an M, then every step is adding a prefix to that base unit. So we have decimeters, which are one decimal place smaller, then centimeters, then millimeters, and we can keep going down. When we're going up, we have decameters, okay, we have hexameters, we have kilometers, and we can keep going up. So the idea of the metric system is everything is moving a decimal. That's a quick, easy review. So if you had 3.3 meters and you wanted to change that into millimeters, then you just look at your little staircase. 1, 2, 3 steps to the right. I move my decimal 1, 2, 3 places to the right, and it is 3,300 millimeters. Easy. I don't really need a calculator. I don't really need to think. I just need to be able to count my steps, move my decimal. The problem is that not everything we use is a decimal system. Welcome to the good old US of A, where we don't use millimeters and centimeters and kilometers very often. Instead, we talk about how 1 foot is 12 inches. And then we'll talk about how there's 3 feet in a yard. And then we'll talk about how there's 5,280 feet in a mile. There's really no rhyme or reason to what we do in this non-metric system. It's not just move the decimal, just multiply by 10, just divide by 100. You really have to memorize all of these other conversion factors. So the problem is, it's not a simple way to do things. For example, if I gave you 2.5 feet, and I asked you how many inches that is. A lot of you can kind of mathematically logic your way through that. You'd sit there in your head, you'd say, okay, 2 feet, that's 24 inches, 0.5 foot, half a foot is 6 inches. Oh, okay, that's 30 inches. Piece of cake. Okay? Where you stumble is when I say, okay, good for you. Now I have 0.431 yards, and I'd like you to tell me how many miles that is. No calculator, go. Yeah, it doesn't work that way, okay? Some of you may be able to do that in your head, and if that's you, then by golly, you're amazing. But for most of us, we need a system. So dimensional analysis is a way that you can do any one conversion. Okay, you can do any conversion you want. You can go yards to miles. You could go, you could go yards to miles. You could go inches to miles. You could go feet to miles. You can go any which way you want. And in fact, it doesn't have to be this. Okay, let's add one in. Let me tell you, 1 inch is equal to 2.54 centimeters. Okay, you could go from centimeters to yards, from miles to centimeters. You can do any unit conversion you want, as long as you have this conversion factor. Okay, that's the purpose for dimensional analysis. It's to go from one unit to another when it's not a straight up easy decimal system. Okay, there's your purpose. So now let's talk about the pattern. Okay, the pattern of dimensional analysis is kind of interesting. So let me give you a conversion factor. Okay, let's say that, we'll stick with the mile. 1 mile is equal to 5,280 feet. Okay? And then let's say that I want to do, let's make up a number here. 3,120 feet. I want you to tell me how many miles that is. Now, I know some of you could just punch buttons in your calculator and get this. But you punching buttons in your calculator, believe it or not, you are doing dimensional analysis. You're just not writing it out. The writing it out will be helpful for later. So even if you're going, oh, I can do this easy, just humor me for a second. All right, so step 1, dimensional analysis. So you're going to draw a cross. Every single time, draw a cross. If I come over to you and you say, I don't know what I'm doing, and you haven't drawn a cross, you haven't tried. Okay? Literally, this is the first thing you have to do every single time is draw the cross. Second thing you have to do every single time is take your given and put it on the top left. Literally, that's it. I have not had to engage my brain once. Okay? I just drew a cross, put my given on the top left. Now, we're going to treat this cross like a big old fraction. So in fraction world, remember, if something is on the top and on the bottom, it cancels out. So we're going to take the unit of our given and put it down here on the bottom. The idea being is if this cross, if you just kind of ignored this little middle part for a second and this was a fraction, you can see that this would now cancel out. And really that's all we're doing. That vertical line is just helping us stay organized, but this is a giant fraction. So now feet are canceled, and I'm going to put the unit that I want, which is miles, up here on the top. Okay, so step 1, I drew my cross. Step 2, I put my given on the top left. Step 3, I put the unit I want to get rid of down here. Then I put the unit I want up top. Last thing I have to do is fill in the numbers right here. How many of these are equal to how many of these? That's where I look at my conversion factor. Okay, 1 mile is equal to 5,280 feet. Mathematically, I can do this because remember, if two things are equal and I put one on top of the other, it's 1. So A over A is 1. Okay, C over C is 1. X over X is 1. So I can put these on top of each other and make them into a fraction because they are equal to each other. What you're really doing here, okay, is it's just a more organized way of saying 3,280 feet. I hope I said that. 3,120 feet, let's try that, times 1 mile over 5,280. This is the exact same thing. These two right here are no different from each other. Okay? Dimensional analysis is both of them. It's just two different formats for dimensional analysis. The cross tends to make life easier when it gets a little harder later on, okay, further down the road. So give it a shot, okay? If you're really getting stuck on this cross, stick with just leaving these as multiplication with fractions and you get the same thing. So how do you solve it? Solving it is exactly what you think it is. It is just like a fraction. So if you look at the top one, okay, the one with the cross, you multiply across here and then divide by what's on the bottom. This makes it a little more obvious, this format down here. 3120 times 1 divided by 5,280, okay, and then you end up getting 0.59, okay? That is dimensional analysis. Really, truly, that is it, okay? It's a very, very simple process. So let's look at another one. You will learn later on this year a whole bunch of different units, one of which is the mole. So let's say I tell you that 1 mole is 22.4 liters. That's something you're going to learn later on. Okay, that's your conversion factor. And now I'm going to say, okay, you have 3.7 moles. Tell me how many liters that is. So, process of dimensional analysis. Step 1, draw your cross. Step 2, put in your given. Step 3, put the unit of your given down here on the bottom, so just like a fraction, it'll cancel out. Step 4, put the unit you want up top, and then last but not least, fill in your numbers. Okay, 1 mole is 22.4 liters. Then, to solve the problem, this becomes basic fraction. We multiply across the top, in this case, that's 3.7. Okay, then we divide by what's on the bottom. Sorry, multiply across the top, which is 3.7, times 22.4. Got ahead of myself there. Divided by what's on the bottom, which is 1. And you get 82.88. And liters is my unit, because that's the only one that's left. That's dimensional analysis. Okay, now, for some of you, you are going to end up sticking to 3.7 moles times 22.4 liters over 1 mole. Perfectly acceptable, all right? It's whatever works for you. But here's why I recommend the cross, okay? Let's do a couple of different, let's go back to length again. All right, we know that 1 mile is 5,280 feet. And we also know that there are 3 feet in a yard. So I'm giving you 2 different conversion factors. So let's say the question that I'm going to give you guys is you have, oh goodness me, 431 yards. I want to know how many miles that is. Okay, that's what I'm asking you. So you go to set up your cross. You're like, bam, I got this. I'm going to put in my given, 431 yards. I'm going to put the unit I want down here, yards, the unit I'm looking for up top, miles, the yards cancels. I got this. You look up top and you say, okay, how many miles are equal to how many yards? Yeah, there's a problem there. I don't know. Okay, without punching a bunch of buttons in my calculator. And again, the point of this is to not do a bunch of work that I never see. The point of this is to have everything laid out in front of you. So if you just went to punching buttons, stop. There's a trick here. What we can do with dimensional analysis is it doesn't have to be a one-step process. Dimensional analysis can actually have multiple steps, 2, 3, 4, 5, 6, 7, however many you need. So what I'm going to do here is I can't go straight from yards to miles. I need a middleman. So looking at my conversion factors that I'm given, I've got this many miles is equal to this many feet. I've got this many yards is equal to this many feet. So the middleman that I have is feet. So what I'm going to do is I'm going to erase my miles. And I'm actually going to change my yards to feet first. Okay, so back to my other system, 1 yard, 3 feet. Got it. But I'm not done. Okay, you could stop if you wanted, make this an equal sign, solve this, and then set up an entire new cross. But you don't have to. What you can do is very simply continue your dimensional analysis. Okay, so now I have feet on top. I want to get rid of feet, and I want to end up in miles. By putting those there, my feet cancel. And I go back up top, and I know that 1 mile is 5,280 feet. Now I can solve this problem. So now when I put this in my calculator, I have 431 times 3, okay, divided by 5,280, and I get 0. Sorry, I'm running out of room over here, 0.24. That's how many miles is 430 yards. So what you're seeing here, you can look at it a couple different ways, is that is one long string of dimensional analysis. It is no different than saying 431 yards times 3 feet over 1 yard times 1 mile over 5,280 feet. Those are the exact same problems. It's just one uses timeses, one uses lines. That's the only difference. The other thing you could technically do is you could say 431 yards, okay, 3 feet, 1 yard, and stop. This is what I was saying before, okay, where you would stop and say 431 times 3 equals 1,293 feet. And now I'm going to set that up as a cross, okay, from feet to miles. The only problem with this method, you'll notice when you do the math, you get the exact same answer. It ends up taking you a lot longer. And when we do ones of these that are 5, 6, 7 steps, you probably don't want to take that long. Second thing you have to worry about when you do kind of this drawn out method down here where you solve it every step of the way is rounding. If you choose to do it this way, there is nothing wrong with that. Okay, yeah, it takes you a little longer, but if it makes more sense, that's a better plan. But you cannot round until the very end. So if this number right here was like 0.73125618, you would have to leave all of those numbers there. If you choose to split it all up, don't round. All right, so the last thing I want to mention with dimensional analysis, and again, this takes practice. So don't expect that you're going to watch this video and be like, oh yeah, I got this. It takes practice. Lots of times it takes one-on-one. Is what do I do with something like, I have 43 grams per liter, and I would like to know how many milligrams per liter that is. Okay, The problem with fractions within a fraction, if you remember this from math class, fractions within a fraction are a pain. You've got to like flip them upside down and remember where they're supposed to be. It's confusing. Yeah, we're not doing that. Okay, when we set up our cross for dimensional analysis and we put in our given, you do not want to put 43 grams per liter up here. Okay, you're going to confuse yourself. Instead, take advantage of the fact that you already have a fraction. 43 grams per liter means 43 grams over 1 liter. That's what that means. So if we split these up, now this is simple. If I look at the beginning, grams per liter, and I look at the end, milligrams per liter, do I want that liter to go away? No, my liter is going to stay. There it is right there, there it is right there. What I want to change is that gram right there. So I'm going to put it down there so that it goes bye-bye. Okay, and what do I want to change it to? I want to change it to milligrams. So I'm ignoring this L. This L is just sitting pretty because now when I fill in my numbers, and again, you'll have to memorize that 1,000 milligrams is equal to a gram. When I fill in my numbers here, I do my math, okay, I get, let me slide down a hair here, I get 43,000. Now look at your units. Milligram is up top, liter is on the bottom, which is exactly what I was looking for. Same thing can happen with the bottom number. Let's say I have 21 grams per liter. We'll do that one again. And this time I want grams per milliliter. Okay, same deal. Draw your cross. Put in your given. And when your given's a fraction, make it a fraction. But now, don't automatically stick that G down there. People do that all the time. They just shove that G in there. That G actually doesn't need to go anywhere. If you look at the end, my G is staying exactly the same. It's the bottom one I want to change. So in order to get that liter right here to cancel out, where do I have to put him? I have to put him on the top. If I put him on the top, he cancels. I put my milliliter on the bottom. Again, you will memorize 1 liter is 1,000 millimeters. And now when you do your math, 0.021, that's 21 divided by 1,000. And now look at your units. Grams is on the top over milliliters, which is exactly what I wanted back at the beginning. Okay, dimensional analysis takes all sorts of forms. Sometimes you change the top, sometimes you change the bottom, sometimes you do a 2-step, sometimes it's a 5-step, sometimes you change the top and the bottom and they're both multiple steps. The point is, know the purpose, know the pattern. The purpose is you're just doing a unit conversion. The pattern is always the same. Draw your cross, okay, put in your given, put in the unit of your given, put in the unit you want, and then put in the numbers, how these two things are equal to each other. Okay, how many of this thing on top equals how many of this thing on the bottom. If you know those two things, you will master dimensional analysis. Just don't quit on it, okay? Keep practicing, keep working with me, you will get this.